In question 2, it says the diagram shows triangle ABC in which BAC is equal to 30 degrees, BC is equal to 6.7 centimeters, and AC is equal to 13.4 centimeters. Now, what's important with these triangles is to identify firstly, do we know that this is a right angle triangle or not? And we don't. So we can't assume that. So straight away, if it's not, we don't know if it's a right angle triangle, then we are going to be using these rules over here. So it says calculate the size of angle ACB. Now, because we've got an angle and an opposite side, we're going to be using the sine rule. So I'm going to be using this rule over here. But I've got B angle, I've got the side B and I've got the side A and A. So I'm actually going to work out angle B and then using it, the sum of all the angles of a triangle add up to 180 degrees. I'm going to use that fact to then find out what C is. So let's do this. So we're going to have A. Now I'm wanting to find the angle, so I can actually switch this around here. So I'm going to get the sine of A over A is equal to the sine of B over B, and so I'm going to get here, in looking at this, I'm going to put the sine of 30 divided by 6.7 is equal to the sine of B, which I'm trying to work out, over 13.4, and therefore the sine of B is going to equal 13.4 times the sine of 30 divided by 6.7. So you work it out on our calculators. So make sure, remember, that you have got your angle in degrees and not in radians. You need to just always check that. Times the sine of 30 divided by 6.7, and we get 1.046. Sorry, I got a mistake here. 13.4 times the sine of 30. I didn't close brackets, and so that caused a problem. Divided by 6.7, and I get exactly 1. So I have the sine of B is equal to 1, and when I do the second function sine of 1, close brackets, I get 90 degrees. So this angle here is in fact 90 degrees, but you couldn't have assumed that beforehand. So here I've got 30 and I've got 90, so this must over here be 60 degrees. So we've got this is 60 degrees. Then it says, I'm just going to erase this, so I've got some space to do the next working. Then it says over here, Nadia makes an accurate drawing of the triangle ABC. She measures BAC to be 29 degrees. Calculate the percentage error in Nadia's measurement. Now, whenever you're working out percentage error, it's actual minus the measured value over the actual times 100. So it's going to be 30 minus 29 divided by 30 times 100. So it's actually going to be 1 divided by 30, 1 divided by 30, and times by 100, and so you get about 3.3% would be your error. Going on to question 3, this one is to do with your volumes, so we're going to be using these formulas over here, our volume formulas here. So it says tennis balls are sold in a cylindrical tubes that contain 4 balls. The radius of each tennis ball is 3.15 centimeters, and the radius of the tube is 3.2 centimeters. The length of the tube is 26 centimeters. Find the volume of one tennis ball. So a tennis ball is a sphere, so we're going to use this formula over here. So the volume would be 4 over 3 pi r cubed, and we'll put in our value 4 over 3 pi times 3.2 cubed, and we put that into our calculators. So we're going to get 4 divided by 3 times by pi, shift pi, times by 3.2, and we going to cube that, and we get 137.25. So I'll write that as 137. Because we three significant figures, I could write this, actually 137 would be fine. I'm going to write it 137.3 centimeters cubed. It's really important to put your unit in. So that's the volume of one tennis ball. It then says calculate the volume of the empty space in the tube when 4 tennis balls have been placed in it. So we really want the volume of the tube. If I just draw it here, I'll just draw the tube like that. We want the volume of that, and then from that we will find the volume of 4 of the balls and then subtract it. So because this has got a radius here, that radius of this is equal to 3.2 centimeters, and the length of this is equal to 26 centimeters, we're going to use this volume of a cylinder. So we've got V is equal to pi r, V is equal to pi r squared h. So it's going to be pi times 3.2 squared times 26, and that will give us the volume of the cylinder. So I just do that. So we're going to get shift pi times 3.2 squared times 26, enter, and I get 836.4 centimeters cubed. So we are wanting to find the volume of the empty space, so that would obviously be the space left over from when the 4 balls are in. So the volume of this empty space, I'll call it ES, is going to equal this 836 minus 4 times this 137, because that's the volume. The 137.3 is the volume of one tennis ball, and there's 4 tennis balls. So I'm going to get that. So I'm going to get my shift answer minus 4 times brackets 137.3 close bracket, enter, and I get 287.2 centimeters cubed. So that will be the answer for this one, and this would be the answer for that one there.